So let's continue with the principal quantum number. As you were talking about the energy of the electron, so the energy of electron is determined by the formula minus 13.6 multiplied by z square upon n square electron volt. Here the electron volt is the unit to measure the energy of the electron. As the energy of the electron is very small in magnitude, so it is easy to measure the energy in electron volt. So 1 electron volt is equals to the 1.6 multiplied by 10 to the power minus 19 joule. Okay. So it is our first quantum number, that is principal quantum number. After that comes second quantum number, that is azimuthal quantum number. Okay. Azimuthal quantum number is denoted by n. Okay, and its values varies from 0 to n minus 1. Now as we are progressing towards the next quantum numbers, all of the quantum numbers will depend on the previous quantum numbers. Like the first we study about the principal quantum number, that is totally independent and we can define it independently. Okay, but the azimuthal quantum number depends on the principal quantum number and its value can be defined or value varies from 0 to n minus 1. Okay, now what is its significance? The azimuthal quantum number tells us about the subshells in atoms and the shape of subshells. Okay, so what are the subshells and what are their shapes, we will talk about later. Okay, so let us define the values for the individual subshell, the values of azimuthal quantum number for individual subshells. So as the azimuthal quantum number is denoted by L. Okay, and the subshells we have are S, P, D and F, and for that the value of azimuthal quantum number for S is 0 and for P it is 1, for D the value of azimuthal quantum number is 2 and for F it is 3. And similarly the shape is defined. The shape of S subshell is spherical, shape of P subshell is dumbbell shape, shape of D subshell is double dumbbell shape, and shape of F subshell is complicated. That's mean the geometrical shape of it contains many curves. So it is quite difficult to define its shape. Now for any value of n, the total values of L will be equal to the n, means in any shell the number of subshells will be equal to the principal quantum number. So here what is it saying, that for any value of n, the total values of L will be equal to the n. Okay, the total value of L. Okay, so the total, let's consider that there is first subshell. Okay, so here we can understand it from the following index, that the shell or main energy level. Okay, so the first shell is, for that principal quantum number will be 1, n is equals to 1, and number of subshells. Now what are subshells? Okay, we will talk about later. So the number of subshells are 1. So in first shell there will be only one subshell, and what will be the one subshell? 1s. Okay, because we will start from S and then we will progress through like S, P, D and F. In second subshell the number of subshell will be 2, because the number of the principal quantum number defines the number, how many subshells will be present in that shell. So principal quantum number is 2, so this number of subshell will be 2, and that will be 2s and 2p. Similarly in subshell 3 there will be 3, in shell 3 the subshells will be 3, and for them the azimuthal quantum numbers will be 0, 1 and 2, and they will be 3s, 3p and 3d. And similarly in shell 4, in shell 5. Okay, so it is the azimuthal quantum number. Okay, after azimuthal quantum number comes the magnetic quantum number. Okay, so magnetic quantum number is denoted by M or M subscript E. Okay, it tells us about the orbitals in an atom and the nature of electron in an external magnetic field. Okay, so without going into the deep complicated language, I will just explain it to you that the magnetic quantum number shows us about the orientation of the subshell or the orientation of the orbitals. Okay, so the subshells like the s shell has not any orbitals. Okay, the s subshell has not any orbitals, but the p, d and f has subshells in it. That's mean the like the p subshell is like this. It has first orbital, second orbital and third orbital. So it has 3 orbitals, unlike the s orbital that has only, unlike the s subshell that is only 1 orbital. Okay, so it is the p subshell. So now come back to the magnetic quantum number. For any value of L, the value of M varies from plus minus L to minus plus L including 0. Okay, so here the value of magnetic quantum number can be 0, unlike the previous quantum numbers, unlike the principal quantum numbers. Okay, so how do we define the magnetic quantum number for any electron? So it is defined like, if the value of L is 0, okay, so the value of M will be 0, as plus minus 0 is plus minus 0 makes no effect to it. If the value of L is 1, so the value of M will varies from plus minus 1 to minus plus 1. That's mean the possible values of L could be minus 1, 0 and plus 1. And for the azimuthal quantum number 2, the value of M can be minus 2, minus 1, 0, plus 1 and plus 2. Now what this value shows? Okay, so let me tell you that the zero azimuthal quantum number, the zero value of azimuthal quantum number shows that the subshell is S. Okay, so if the subshell is S, and for that the magnetic quantum number is also 0, that means its orientation is same in every direction. That means if I measure its, as its shape is spherical, so if I want to determine its orientation according along the x-axis or along the y-axis or along the z-axis, it will remain same. But for the axis, for the orbital p, for the subshell p, because the azimuthal quantum number's value is 1, and if the value of L is equals to 1, then it defines that it is the subshell p. So the subshell p has 3 magnetic quantum numbers. So what these 3 magnetic quantum numbers shows? Okay, so they show the orientation of the p orbital along the all 3 axes. That's mean the minus 1 shows the orientation is along x axis, 0 shows the orientation is along z axis, and y shows the orientation is along y axis. Okay, so what do they define? So let me clarify you that there are 3 axes. It is y, it is x and it is z. So if the value of M is minus 1, so it will simply mean that the p orbital is like this. So it can be said that it is along the x-axis, or it is it is situated along the x-axis. Or if I say that its value is plus 1, so that's mean it is along the y-axis like this. Okay, it is py, it is px. And if I say that its value is 0, that's mean it's along z-axis like this. So the magnetic quantum numbers defines the orientation of the subshells. So now let's tell me about the orbitals, shells and subshells. So the shells are the outermost part in which all the electrons are situated. Okay, and about shells, we the principal quantum numbers tells us about the shell. Okay, so in which shell the electrons are situated, and how we go, and when we go further in deep, we come to know that the electrons are not freely situated in only shells. In shells, they are arranged in the subshells. The subshells can be, for let's consider that this is a second shell, and in second shell there will be only two subshells, that will be 2s and 2p, and in 2s and 2p there will be first 2s and 2p, and in 2s only maximum 2 electrons can be filled, and 2p maximum 3 electrons can be filled. So 2s has no further orbitals, but 2p has further orbitals. That means 2p can be further divided into individual units. That means this is first orbital, this is second orbital, and this is third orbital, and we can define them like px, pz, and py. Okay, so electron can be present in any of these. Okay, so to define their values, to define the position of electron, we need the magnetic quantum numbers. If we have only the principal quantum number, we only know that the electron is situated in the second shell, and if we have the azimuthal quantum number, we can tell if azimuthal quantum number is 0, the electron is situated in s orbital. Okay, there is no mistake. And if azimuthal quantum number is 1, then how will we determine that if it is situated in px, pz, or py? So to clarify this, we need to determine the magnetic quantum number that tells us about the correct position of electron. So if it is -1, then electron will be situated in px. If it is 0, electron will be situated in pz, and if it is y, the electron will be situated in py. So that's all the significance of the quantum numbers. Okay, and the last quantum numbers that we are going to study is spin quantum number. So spin quantum number is unlike all the previous quantum number, and it's the difference between the spin quantum number and the rest of the quantum number is that it is independent of the previous quantum number, and it only tells us about the spin direction of the electron, that if the electron is moving in clockwise direction or anti-clockwise direction. As we know that electron moves about its axis or moves about its own axis. So what will be its direction of spin? So the direction of spin is shown by spin quantum number, and it is denoted by s, and its possible values is only 2, +1/2 and -1/2. You can assign either of these value to the clockwise or anti-clockwise. If we assign the +1/2 to clockwise direction, then -1/2 will be automatically assigned for the anti-clockwise direction. Okay, and vice versa. So that was all about the quantum numbers. Okay, and how the quantum numbers tell us about the position, energy, and the behavior of electron in magnetic field. Okay, quantum numbers are also used in the electronic configuration of the atoms. Okay, so that was all about the quantum numbers for the atoms or electrons.